Dear students, today's session Coimbu University BSc 3rd semester Geometrical Optics chapter session 2. Myself Dr. Niranjana ER, Assistant Professor of Physics. Optical system and cardinal points. Single lenses are rarely used for image formation as they suffer from various defects inherent in them. In optical instruments such as cameras, microscopes, telescopes, etc., a collection of lenses are employed for forming images of the objects. An optical system consists of a number of lenses placed apart and having a common principal axis. The image formed by a coaxial optical system is good and almost free from aberrations. First, let us understand the basic sign conventions. See the figure. Direction of light. It is negative axial distance. Distance above the axis is taken as positive. Positive axial distance. Distance below the axis is taken as negative. From the above figure, sign conventions can be taken in analysis of image formation in an optical system. Incident light travels from left to right. Second point, origin is O and it is always along the axis XY. Third point, distance measured to the left of O taken as negative, distance above and normal to XY axis as positive, and that in downward are negative. Cardinal points. The thickness of the lens has been neglected while discussing the image formation and establishing the various formulae in case of refraction through a thin lens. But the same thing cannot be applied for an optical system consisting of combination of lenses. In 1841, Gauss showed that any number of coaxial lenses could be treated as a single system. The lens maker's formula can be applied to the system provided the distances are measured from two hypothetical parallel planes fixed with reference to the refracting system. The point of intersection of these planes with the axis is called principal points or Gauss points. There are 6 points in all which characterizes an optical system. They are two focal points, two principal points, two nodal points. These 6 points are known as cardinal points of an optical system. The planes are passing through these points and which are perpendicular to the principal axis are known as cardinal points. The cardinal points and cardinal planes are intrinsic properties of a particular optical system and they determine the image forming properties of the system under consideration. Principal points and principal planes. See the diagram carefully. Consider an optical system having its principal focal points F1 and F2. A ray OA traveling parallel to principal axis and incident at A is brought to focus at F2 in the image space of the optical system as in figure. The actual ray is refracted at each surface of the system and follows the path OABF2. If the incident ray extended forward and the emergent ray BF2 backwards, then they meet each other within the optical system at the point H2. The refraction of incident ray OA can be described in terms of a single refraction at a plane passing at H2. The plane drawn through the point H2 and perpendicular to the axis may be regarded as the surface at which refraction takes place. This plane is called the principal plane of the system. Thus, the four consecutive deviations of the light rays caused by the four surfaces of the optical system are equivalent to the single refraction at H2 taking place at the principal plane. Principal plane of the optical system is defined as the loci, where it is assumed that the refraction to occur without reference as to where the refraction actually occurs. H2P2 is the principal plane in the image space and is called second principal plane. The point P2 at which second principal plane intersects the axis is called second principal point. By adopting the similar procedure in the object space, first principal point P1 and principal plane H1 are defined. From the figure, it is observed that the two incident rays are directed towards H1 and after refraction seems to come from H2. Therefore, H2 is the image of H1. Thus, H1 and H2 are the conjugate points and the planes H1P1 and H2P2 are conjugate planes. H2P2 is equal to H1P1. Focal points and focal planes. If a parallel beam of light from left to right is incident on the optical system, the beam comes together at a point F2 and is called second focal point. Similarly, on the object space, the point F1 is called the first focal point F1. First focal point F1. It is the point on the principal axis of the optical system such that a beam of light passing through it is rendered parallel to the principal axis of the optical system after refraction through the system passing through it. Second focal point F2. It is the point on the peripheral axis of the optical system such that a beam of light traveling parallel to the principal axis of the optical system after refraction through the system passing through it. The planes passing through the principal focal points F1 and F2 and perpendicular to the axis are called first focal plane and the second focal plane respectively. Nodal points and nodal planes. Nodal points. These are pair of conjugate points on the principal axis of the optical system having unit positive angular magnification. The ray directed towards one of these points after refraction appears to proceed from the second point in parallel direction. Nodal planes. The planes passing through the nodal points and perpendicular to the principal axis is called nodal planes. Let us discuss some multiple choice questions. First one, number of cardinal points in a lens system is 2, 4, 6, 8. Answer is C, 6. Next question, the distance between two nodal points is always dash to the distance between two principal points. Options are equal, unequal, higher, lower. The correct answer is equal. Third multiple choice question. The distance between principal point and focal points in the lens combination is known as first length, simple length, equivalent focal length, principal length. Answer is C, equivalent focal length. References: Optics by Ajoy K. Ghatak, 6th edition TMH Publishers. Textbook of Optics, revised edition for BSc classes as per UGC model syllabus. Authors N. Subramaniam, Brijlal and M.N. Avadhanulu, S. Chand Publishers. Third reference, Optics by R. Murugeshan, S. Chand Publishers. Fourth reference, Fundamentals of Optics by Jenkinson and White, 4th edition TMH Publishers. Modern Optics by A.B. Gupta, Books and Allied Limited Publishers. And some two internet links are provided as reference.